My many colleagues here and young friends. I am grateful for being invited to give this lecture. I am always interested in talking to young people. I find my best to find the time to do this. Today, I first thought I would talk about many of the things I normally talk about, something about science or something about some recent important developments in science. But I decided not to do that. I thought I would make this a bit autobiographical, at the same time talking about science itself. How to do science in India. Can we ever succeed in doing science at the highest level in India? Doing science in India, that is the topic. What do you mean by doing science in India, I may say? I think I have earned rights, marginally at least, for talking about this, because I am doing research for the last 62 years, of which about 55 years I have been a professor. This is my 55th year as a professor in India, and I have had a large number of students who have did their research with me. And of course, I have also taught a number of undergraduates and so on. So I hope you will pardon me for assuming that I have the right to talk about doing science in India. Let me remind you that when I was young like you, India got freedom. I just entered college when India got freedom in 1947. I still remember that midnight of 15th August when I went around the city of Bangalore with bells and gongs celebrating the freedom of this country. In fact, as I was entering college, it was very clear that India is going to have many challenges. I still remember the great speeches of Pandit Nehru and all other leaders of that day. But the early days of independence were very difficult days. We were a very, very poor nation. I will never forget the kind of laboratories we had, not comparable to what we have today. But anyway, I somehow at that time, when I was 17 years old, I decided I want to become a scientist. In fact, many people said I must become an administrator, go for administrative service exam, this, that. I said, no, I want to be a scientist. Fortunately, I had parents who allowed me to do whatever I wanted. They never interfered with what I wanted. And then I went to Banaras University, which was a very great center for research at that time, to do my master's degree. When I was about 19 years old, I got my master's degree in chemistry. And at that time, I got terribly inspired doing research in BHU for my master's degree by the work of Linus Pauling. Linus Pauling had just then solved the structure of the alpha helix. I didn't know what alpha helix meant at that time, but the fact that people can solve structures of molecules and proteins so well, that impressed me. I thought I must work in such an area. It is this that took me to the United States, where I did my PhD and postdoctoral work for many years. And at that time I had already established myself rather well, even though I was about 25 years old, when I finished my postdoctoral work in University of California, Berkeley. And everyone thought I was going to settle in the United States. In fact, I had offered faculty positions in 3 major universities. One university were promising that within 3 years I would be promoted, probably as an associate professor. But somehow I thought I had published about 28 or 30 papers by that time. I was exactly 25. Then I decided to come back to India. The main reason being the bells and gongs I told you about on the 15th of August 1947. I could never forget that. I could never forget where I came from, my family, particularly my mother. And so I came back. What did I see when I came back? Nothing. There was no facility to do the kind of things I had done in the United States. There were no spectrometers, there were no diffractometers, there was nothing. In fact, the only thing you could get in plenty was a lot of thread and wax. And if you wanted to build a furnace, you had to get heating elements from somewhere. had to build my own build everything. I did my best. Somehow decided to work in India with those meager facilities, which were nothing, zero facilities. How do I do spectroscopy without a spectrometer? This is the kind of problems I face. I still did. I still published 100 papers then, going here and there, borrowing something, using somebody else's facility. In fact, I used to go with empty suitcases to America for 3 or 4 months to work there, come back, suitcases full of chemicals, wires, thermocouples. Fortunately, nobody used to bother me in the customs in Bombay at that time. And I would, if you brought all the white and black powders today, they will not allow you to enter India. Anyway, much of the research was based on things I borrowed and stole and all kinds of things. Yeah, I had to steal here and there, a little bit here and there. And when there was no business, you may not believe it, there was nothing called foreign exchange. You could not order any chemical or any equipment from outside India. And then there was an international conference, I'll never forget. I had to go for an international conference. I was a young boy. I was about 27 at the time, or 28. And I was asked to give a short talk. I was amazed because there was some small thing I had done here. And the government of India gave a grant of $8. Well, people will laugh at only $8 to go to America. Yeah, that was it, man, that was it, $8. And I went with these $8, didn't know what to do. I returned to every friend I knew in New York so that at least one of them will come from the airport to take me somewhere. It was really unbelievable. It is a fact, it's not a lie, it's not an exaggeration. We went through those poverty-stricken days. Slowly, India started building institutions. The poor laboratory became slightly better laboratory. From poverty, became to lower middle class in science, with some facilities. When I went to IIT Kanpur as a professor, I was about 30 years old when I became a full professor, and I was the first head of the chemistry department in IIT Kanpur. I could build a fantastic department. We had reasonable facilities, but everything was public property. There would be a spectrometer, but the community had to use it. There was no dedicated instrumentation. Anyway, I did a fair amount of work then. So then I decided I'm going to work on chemistry of solids and chemistry of materials. And of course, that was not in fashion those days. Very few people worked on that in the world. Many people even think that I'm one of those grandfathers in the subject even today. But anyway, I started working on many of these things and started publishing all kinds of things. It's only from lower middle class eventually became a fairly real middle class. It's only in the last 15 years or so I have fantastic laboratory. And my laboratory today in Bangalore is second to none, is as good as, probably even better than one in Cambridge University, or as good as the best in the world. But I had to wait for 40 years for that to happen. It was a highly agonizing wait. Terribly, somebody said, what is success in India? It's very difficult to say what success is because we have so many failures before that. Just like you don't know what accomplishment or what good facilities mean because you have had such bad facilities to start with. So, absence of success for a very long time. But in spite of all this, I must say, we could do some things where there was no equipment and you would mind a bit more. When there are equipment, people stop using their brains, they say. Because the equipment, there's the thinking. But anyway, it has been a wonderful journey. Today, of course, in India, with a reasonable amount of money available, science is growing, facilities are available. Well, at least we have a few institutions with outstanding facilities. In spite of that, where are we in India today? Are we one of the best nations in the world in science? I'm afraid not. India is still, well, reasonable. I would not say in the top countries in the world. In innovation, as you know, recently they have announced the merit chart and innovation in the world. Out of the 144 nations, India is 66th in innovation. In science, are we in the top 5, 10? I'm afraid not. In quantity of science that has been done, we have not improved in the last 30 years. We are still producing around 2.5 to 3% of world research from India. China, which was very similar, of course, is now producing almost 15% of world research. By next year, China will overtake the United States in quantity of research. Of course, in quality, it will not for a very long time. America will continue to dominate the outstanding quality research in the world for a very long time to come. But what has happened is, Even though we are doing reasonably well, others are doing better. Although we are investing some, others are investing more, and we have a tough competition. If you go to a country, not mention China anymore because it's too obvious, everyone mentions it. I've just been to South Korea 2 months ago. There was a fantastic symposium organized by the Nobel Committee in Chemistry from Sweden in South Korea, where I was one of the speakers. What South Korea has done is extraordinary amount of money, the institutions, and enormous infrastructure, and so on. When you see that, you feel that you have to invest more, you have to do more. Obviously, one of these days, our governments will give more. And I do not want to blame governments alone. Our industry has to give more. Our industry is giving almost nothing for research till now. As far as though I worked for 55 years in India, I went to get my first 5 rupees from industry. I want most of my money is from government of India, and that is true of all our organizations. And only, unlike South Korea, where 45 to 50% of the research is supported by industry. So I hope things will change. And I'm not going to talk about funding today, that is not the purpose of my research. The question is, how are we going to do research which gives you success? Let me tell you 1 minute about myself. Even though I started with leader funding, somehow I always try to pick those problems which somehow will make an impact somewhere in that subject. Had reasonable success in the beginning, fairly good success in the last 20-30 years. Well, so I do not want to say more than that, except to say that I have been able to work in competitive areas like superconductivity or colossal magnetoresistance, recently particularly multiferroics, and so on. In the last 2-3 years, I decided, somehow I found in India, however much I urged young people to work on artificial photosynthesis, because there is one way of making hydrogen and do many other things with it. I decided to start work on artificial photosynthesis about 2.5 years ago. I'm having fantastic results now, because I just published a very important paper in Proceedings National Academy of Science in the US on one of the things where there is artificial photosynthesis. I'm doing many of these things. So life has not been bad at all in terms of my own research, and I've had reasonably good response for whatever I have done. I've had, in fact, though I hate to say this, I've had more response and more support from my research from outside India than from India in the academic sense. I think people from outside have appreciated my research much more than in India yet, because I don't know in India whether we are doing the kind of research that is competitive enough to even to notice what is really good work, what is not. This is what we are doing. When is India going to be competitive in science? Where it is at the very frontier? China is trying hard, South Korea is trying hard, of course, other countries are already there. When do we become the top one of the top 5 countries in science? When I look at it, the problems I see are not financial. I somehow feel science has not got the kind of importance it should in our society. In fact, in the value system in India, if you say, I think science will be somewhere in the bottom. Nobody will mention science as an important thing in India. They will mention business, banking, foreign investment, cinema, sports. Eventually, maybe science may figure in the bottom somewhere. Nobody talks of science as very important. In society, I don't think we have science as an important thing. I think that is very important for us to remember, because without that, science will not get the due recognition it requires. Even though they get money, somehow you need an entire ambience, entire society supporting morally, philosophically, and providing that support for science to thrive. I don't see that happening. I feel very sad about that. In fact, science becomes sort of a secondary to most things, and somehow, of course, there are organizations doing science, technology, that is there, but it's okay. When they think of science, they think of some little thing that may happen somewhere. The overall science, as I understand, where is the exploration of the unknown, working at the frontiers in science, that you create new ideas, you create new technologies, you do things which may directly affect mankind in some way. You do many things in science. When that type of research, where that type of effort in science, which is involved in creative, which is a creative creative endeavor, I do not think we are interested. In fact, somebody asked me, suppose everything is stopped, nobody gives you money, what happens to science? Somebody asked me a question like that when I was in Korea. Well, I told him, science will continue independent of all money. That is the science I am talking about. Science, which is the result of a creative urge of man. That creative urge of man will not stop, and it is independent of all support. And that science is one that I am talking about. We need that type of high quality of science when man stretches himself beyond his capability, thinks of ideas that have never been thought of, works in areas which are difficult, works in areas which is useful. This is the kind of science India should be doing. Are we working on problems of medium importance, whether it is energy or water or food? Are we working on problems which are in the very frontier in physics or chemistry or whatever? This is the thing that then I think India will be known as a great scientific power. To do that is not money alone, it is a determination. Or if we people somehow seem to compromise to mediocrity, and our society also in a country where failure is not appreciated. You know, lots of good efforts in science fail, and in India if you fail, by God, they write articles about it. You know, in fact, people, if you succeed in India, it's very difficult. Our society is such, even scientists are such, they look for some fault in the people or the person and pull you down. It's a very difficult society to work in. We have to change where success and failure are treated equally. Failures happen when you do a major project, you fail sometimes. So what? You'll succeed next time. We do not think like that. Oh, failure is no good, they are saying. In fact, they make up their mind about an issue or a science or a project much before they know about it. In fact, truth does not matter in our society today. In fact, if truth mattered, there will be no TV programs left. Because there will be one truth only for every issue. But there is no argument, you just find the truth. But nobody wants to find it, because there will be no TV program. There are all kinds of controversies, they enjoy that. Lots of TV shows. The same is indirectly true in science, because I'm not worried about criticisms and so on. What I'm talking about is, we must not be afraid to make mistakes in science. We should not be afraid of taking challenging problems. This fear of failure has prevented a large number of people to work on difficult problems. I talk to young people, very smart, much smarter than myself. I know why they are working on easy problems, because it is safe to work on them. They go on repeating themselves, the 100 carbon on the same paper they wrote long ago. They go on publishing in good journal, nobody reads. So in fact, somebody said, you have answers to all the questions never asked. So there's no point doing research of that kind. You may publish it, but nobody will read it. So we have to graduate from that level. But graduate from the level where we publish just to satisfy our own ego, but publish where it is competitive area, important area, exciting area, it is challenging, the country needs it, the world needs it, science needs it. That is the kind of science India should be doing. And so, in spite of the judgmental society we are in, we have to graduate from that and come to this level. Well, having said all that, is it difficult to succeed? Well, it is. It's extremely difficult to succeed. That's why you see, H index of very few scientists is very high in India. Citations for India is not very high. Partly because people do ignore work from India. In fact, my friend from Russia was saying, the Russians and Indians don't get quoted, he was saying. Maybe that is true, I don't know. I can't say anything more about it. All I can say is, leaving all that citation indices of one sort or the other, there's no question that in my mind that we also have to pick the right problem. As Michael Faraday once said, it's picking the problem in science that is important. Doing is the easy thing, that's what Michael Faraday said. And that's true. We should pick the right problem so that we can have many stars in India. The reason I decided to talk about today is, I'm talking to young people. Of this, even 10% of you become scientists and you become stars. Oh, I'll be the happiest man. I won't be alive, I'm too old, I won't be alive that long. But 20, 30 years from now, some of you will be stars. To do that, don't ever forget, don't compromise to mediocrity. Don't ever accept something that is secondary. Do pick up problems of the highest quality and work in India. And work in India will get recognized eventually internationally, and what little success I've had is what little determination I had all these years. I'm not saying I'm the best example, not at all. All I'm saying is, I've been fairly lucky. I've had a fair amount of response. Other countries, everybody in the world has been very nice to me. But I know we can succeed, but we would have to work very hard for it. And that is the thing about India. It is a land of karma where you have to work very hard to succeed. If you don't work hard, nothing happens. In fact, there are stories in our mythology, stories everywhere to tell you India has always been a land where you work very hard to get a little result. You have to continue therefore work very, very hard. So when talking about this, I thought I must say a few words about what about people, scientists who have succeeded in the world. Scientists who have worked against all odds. Scientists who think differently, who do different things. I think I will spend a few minutes about that. In fact, I have found, you may not believe it is true, you always need some source of inspiration to do outstanding science. It may come from your laboratory, it may come from your family, up to a point, but eventually, in the highest idealistic sense, you need somebody to inspire you. In fact, I've had some people who have always inspired me in science. Michael Faraday has always been, I'm tired of reading or remembering Michael Faraday and his work. And there are many examples of that kind in science. So I thought I would spend a few minutes talking to you about, it is not coming, something happened here. Okay. Turn off that. Intuition and inspiration in science. Intuition and inspiration play a very important role, both of them. I would like to go through a series of pictures of great men who have done science, great science. And how did they do it? Is a question. I don't know whether you thought about that. You please think, if you want to do good science in India, keep thinking about those people who did against all odds. How did they do that? Why did they do that? And that answer would be, well, we don't know how they did it. Let us try to do something like that. Now, I will go back 18th century and 17th century. You know, it always amazes me. Newton did all these fantastic things in mechanics and so on. So long ago, when physics was not well developed. In fact, there was a big plague in London. I hope you all remember. Because of the plague, he went away to his village. And he sat in the village and did all these fantastic things, including calculus. Suppose there was no plague and he didn't go to the village. Would we have still done that? I don't know. All I can say is, how did he just sit there in his country house and did all that? And more equally interestingly, Lavoisier. When Lavoisier started working in chemistry, there was no chemistry. Chemistry was not known as a subject. Chemistry became a subject only in the 18th century. Physics was known because Newton was there in the 17th century. When Lavoisier was there in the 18th century, chemistry was unknown. He was the first one who talked about laws of chemical combination. He was the first one who talked about air has oxygen and nitrogen. And unfortunately, look at his life. When he did all this fantastic thing in such a way that he is now considered to be father of chemistry. He was the first chemist of the world. Unfortunately, there was French Revolution, and he was very close to King and Queen of France, and his head was guillotined, along with that of the Queen and the King. And we lost this very great man, his neck was cut off at that time, in 1794. And then come to the greatest mind that we have always known. I am never tired of talking about Faraday to young people. Don't ever forget, at least in my opinion, it is the opinion of many people like me, the greatest scientist in the history of science is Michael Faraday. To me, there is no one else who can beat his record. The reason is the following. He had only 3 years of schooling, don't forget. He didn't know enough mathematics, he didn't even know enough English, but he slowly, he was joined as an assistant to a bookbinder. As an assistant to a bookbinder, one day he wrote a book on electricity by voltage, and then when he was doing that, some rich customer came to the shop of the bookbinder, and this bookbinder tells him, sir, here is a young boy who is very much interested in science, and he has just now bought the book on electricity. And this man says, oh, he's so much interested in science, you know, I have got 3 tickets to the lectures on chemistry being given by Sir Humphrey Davy. Maybe he can use it. He gives 3 tickets to this young boy, Faraday, assistant to the bookbinder. He goes and attends these 3 lectures, the Humphrey Davy's lectures. And then, of course, being typical Michael Faraday, in his beautiful handwriting, he he took down all the notes based on the lectures. As soon as he came home, the third, fourth day, he bound it as a book. 3 lectures by Humphrey Davy. He wrote that, bound that book, went to Humphrey Davy and said, "Sir, I bound the lectures you gave. As usual, all of us senior people, well, very good," they said, he sent him away. Because before going, Faraday asked him, "Sir, do you think you can give me a job in your laboratory?" "Well, there are no jobs here, no vacancies." I'm sure directly tells that to many people. But anyway, all of us do that. Poor man, I don't want to go on. But anyway, but what happened amazingly is, the whole accidents take place about doing science. A month later, there was a boy who was cleaning the laboratory in Sir Humphrey Davy's laboratory. By that time, Davy had already discovered sodium, very great scientist, and that boy runs away. Then he remembers, that boy Michael Faraday, why don't I call him and give him a job? So he calls him and gives him a job. What do you think was his first title? Chief Bottle Washer. That was the first job of Michael Faraday. Chief Bottle Washer in Humphrey Davy's laboratory. And he started working in the laboratory, helping Michael, very good assistant to Davy to do experiments. So he started doing his own experiments. In 1816, Michael Faraday wrote his own paper, first paper. Just, he learned enough to do his own research a little bit. Something on calcium carbonate, I will not bother about it. It is very interesting. 1816 is a very important year because exactly 100 years before 1916 was when chemical bond was defined. So 1816 was the first paper by Michael Faraday. And he started doing many things, Michael Faraday, and slowly he discovered so many things independently. In fact, Lord Rutherford had asked, if only he lived in the 20th century. He said, Michael Faraday was in the 19th century. There was no Nobel Prize. And Lord Rutherford said, if only he were in the 20th century, he would have got 5 Nobel Prizes. That's what Lord Rutherford said. I have counted very carefully. I think he would have got at least 4 Nobel Prizes if he were in the 20th century. Well, what are all the things he did? I hope, let me remind you, laws of electrolysis probably got a Nobel Prize. Discovered benzene, the organic elements would have given a Nobel Prize. Discovered electricity, maybe he would have got a Nobel Prize for that. I don't know about all. But what was amazing was he was a very simple man. In fact, when the Royal Society elected him as a fellow of the Royal Society, and when one day they wrote to him, "Dear Mr. Faraday, we would like you to be the president of the Royal Society, which is a great honor." And he said, "Thank you very much for this great honor. My place is in the laboratory. Please excuse me, I do not want to become president." How many of us do that? Any little job, any little promotion, any little advancement we take up. You see, science is such a demanding master. If you are wedded to science and you want to do science as a great thing, don't be tempted by anything, including presidentship of the Royal Society. Okay, that is Faraday. And I want to come to India. I want to show this man. Because many Indians do not know the story of J.C. Bose. It's a great pity that we don't teach enough about our own scientists. I think he was the first great scientist of India. He was a man who in 19th century did an extraordinary experiment in Calcutta. He had come back with a BA degree in physics from Cambridge University, was teaching in Presidency College. He is the first one who did experiments in telegraphy in Presidency College. Unfortunately, his work was used by Marconi. At that time, there was not enough recording, whatever, priorities and so on. Of course, Marconi alone got a Nobel Prize, which should have been shared between him and J.C. Bose. Royal Society and also many other organizations, including in the US, have written fantastic reviews of how J.C. Bose got cheated out of some of this. But anyway, it's amazing. Why would a man in 1895 sitting in Calcutta do this experiment? You imagine the British were ruling then. 1895 was, I hope you all know what years mean. 1895 means it is before the discovery of the electron. The electron was discovered in 1897. So this man did this fantastic experiment on microwave before the discovery of the electron. In Calcutta, there was no science. An extraordinary story. And what is interesting, one story, he wanted 2,000 rupees for his research laboratory. He write to the resident, I don't think you all are young, you don't know. We used to have a resident in Karnataka, resident in Calcutta, representative of the British government. He asked him, "Dear Mr. Resident, I need 2,000 rupees Can you please give me? Then he gets the reply back. How dare a native scientist like Bose ask for money from the British government to do his research? He should save money from his salary and do it. That is the reply he got. And anyway, eventually the Viceroy of India interfered. Eventually, he got him 2,000 rupees to do his research. Then leave that aside. Here is the man. This is the kind of question I ask. Why is it? How come we are all in such a happy state now in India? This man in 1895, why did he? He was a very spiritual man. I don't know what made him get up science and go on doing experiments till the end. It's amazing. He was so spiritual. Toward the end, he was always seeing the river Ganges going near his house. One day he said, I must go and see the origin of Ganges. He starts walking. Those days there were no planes, no trains, not even a bullock car to take you to the Ganges. I don't know whether you have been to the mountains. Even today, to go to the origin of Ganges, you have to walk a lot. And those days he walked miles and miles, and then eventually he goes there and asks somebody, I say, where is origin of Ganges? Where is Gangotri? Where is that Gomukh where the Ganges is born? He says, you see those 3 mountains, hills, you cross that, then you will get that. He walked and walked. Then he fell unconscious by the time he reaches. It's a very well-known story about this great J.C. Bose, one of the greatest modern scientists India had, the first modern scientist in India. I want you to know that. Before anyone else in India, he was the first modern scientist. I show another example. Another 19th century man, born in 19th century, died at the age of 32. He wrote 3,000 and odd theorems and conjectures in mathematics without any college education. Srinivas Ramanujan flunked with school, so he couldn't go to college. But he did his mathematics beyond the imagination of any other person even today. How did he do that? You young people think about it. Here is a man sitting in the interior India, somewhere in the south, writing away equations of equations. There was no paper. I don't know many of you don't know that. When we were young, we never used paper. People went to high school or middle school. Till then, we used a slate and went on writing on a slate. Everything was rubbed it off. All his mathematical things he did on a slate, and all the proofs he rubbed it off. Only the final result he wrote. So he wrote so many final results. Hundreds of people are still working on Ramanujan's conjectures and theorems. Mainly because he didn't write down the details. It's all in the slate which he rubbed off. How did he died at the age of 32? Many people tell me, my friends in Princeton and Cambridge, if you are only to pick 3 mathematicians on the earth, the great mathematicians, he will be one of them. Some of them tell me, I'm not a mathematician. 3 or 5 doesn't matter. But to be considered such a great mathematician, from India, from deep south, without college education, and without scholarships and professorship, amazing. How did he do that? Or why did he do that? This is the thing that I talk about. Science needs that extra thing. It is not money, it is not government, it is not science department, it is not fellowship. That is J.C. Bose and Ramanujan. Of course, I don't want to talk about Raman much, is very well known. Here again, what I used to know Professor Raman very well. Extra was very, very good to me all through. He was the first one to recognize me in India. I'll never forget it. I was 29 years old when I got a letter from C.V.Raman one day. I said, Dear Professor Rao, at that time I have just become Professor, 29. Dear Professor Rao, I've seen your latest book on infrared spectroscopy. I think the book is worthy of making you the Fellow of the Indian Academy of Sciences. If you don't have any objection, I'll see that you are elected as Fellow of the Indian Academy. I'll never forget it. He was very, very nice. The reason that amazes me about Raman is not about his Nobel Prize. Of course he got a Nobel Prize. When he actually started doing research, he was an accounts officer, or it was called Assistant Accountant General or Senior Accounts Officer in Nagpur. Nagpur even today is not easy, the center of India. And during evenings he used to go to the science college to do experiments. How many will do that? How many accounts officers there are today? Or how many professors, even they are full-time when they are in the professor IIT, they don't go to the lab. And that's true. You find in Indian Institute of Science, where I have been a director, I never go for coffee or I never take coffee breaks. When I go in the morning to evening, I do at least 10 hours of continuous work. I never leave my room. But I find my young professors, they go for coffee, 5 to 6 hours in a day go for coffee and tea. So very little time for research. Of course, Poor Raman used to go evenings to this college and to do his experiment. And you know what? You may not believe it. He started his work on musical instruments, as you know, in Nagpur. And based on that work, he was elected fellow of the Royal Society, became an FRS. Based on the work done in spare time during evenings, now he was full-time accounts officer in the daytime. I've been a fellow of the Royal Society, how many years now? 35 years or something. Very long time. It's not easy to be an FRS even today. But he became an FRS then, doing experiments in the evening. Of course, even in Raman effect discovery, was working during evenings, even though he was an accounts man in the government of Britain, British government in those days. And this is what is amazing. What made Raman do this? Go in the evening to a miserable college doing experiments. When we have all the facilities, we don't do that today. It's just amazing. Okay. Science has also had great teachers, that's very important. We need great teachers. Which means that somebody asked me, what is the most important thing for India to shine in the next 20 years? Teaching and teachers. India has to become a great teaching nation. Today, Indian teachers, schools are at the worst level possible. Even the best school is not good enough. Particularly if you go to rural India, our schools are one teacher schools, hardly any teaching going on. I think we should make a national mission about teaching. Teaching is very important. I hope you know that. Now in teaching, the number one country in the world is Finland. America is not very high, it's about 25 or 30 the ranking. The first country in teaching is Finland because the teacher gets so much respect in that. It's difficult to become a teacher in Finland. Oh, I'm sorry. Anyway, there are great teachers like Samarkand. All the great physicists of his time were trained by him. Heisenberg, Pauli, Max Born, Hans Bethe, Piles. Mention any great physicist and they all were schools of one man. This is the beauty. We should have such schools where, great minds come out of these schools. Every physical chemist known to me in the early 20th century were all students of Oxford. Doesn't matter which name. Whether it is G.N. Lewis, whether it is Nehru or Arrhenius, mention any name, they are the students of Oxford. In fact, I have a new story, this is just a joke for you to. My teacher in Banaras with whom I worked, did my MSc thesis, worked with another professor in London for his doctorate, S.S. Joshi, with whom I worked. He worked with Donnan in London, in University College. Donnan was a student of Oxford, so Oxford is my great-grandfather. And then I used to tell the story about Lewis. You see, many of you know Linus Pauling. Linus Pauling is my guru. I will not talk too much about it today. I may be mentioning. Linus Pauling is one of the greatest chemists we produced in the 20th century. But the man who is above Linus Pauling to me in chemistry is G.N. Lewis. G.N. Lewis came with so many new ideas. He is the first one to talk of the idea of the chemical bond. I hope you all know that. In the year 1916, the first paper on the chemical bond was written by G.N. Lewis. It is Linus Pauling who gave shape to it much later, but the great chemist who gave chemistry shape, form, first chemist to do that was G.N. Lewis. But unfortunately, he never got a Nobel Prize. Every student of his got a Nobel Prize, except G.N. Lewis. It is a story, unbelievable, because I have read all the original literature of the Swedish Nobel Committee. There is a book, in fact, about that recently by somebody has written. It's amazing. And he was nominated 18 times Nobel Prize for chemical bond. And the Nobel Committee said, I don't think chemical bond is an important thing in chemistry. They didn't believe him. Of course, then he did Lewis acids and Lewis bases. Well, they said, Lewis acids and Lewis bases, I don't think people will accept it as an important. Today, everybody uses Lewis acids, and they don't even know Lewis was a scientist. They think the Lewis means something else. And he didn't get Nobel Prize. So it was one of those stories. In the end, one of his students whom I knew, Harold Urey, discovered deuterium. Deuterium is an element that, a heavy element, of course, or Kakodkar will know deuterium, because of heavy water. The first man who made heavy water in the lab successfully was G.N. Lewis. And he said, what is the use of a deuterium element unless you make a compound? He made heavy water. And he used to send little capsules of heavy water to anybody who wanted to research, study thermodynamics, spectroscopy, effect on protein, wrote 23 papers on heavy water. And then, in the end, Nobel Prize was announced only for deuterium to Harold Urey, no G.N. Lewis. One of those terrible things. And he is my grandfather. An old man, you see, I did my postdoctoral work with J.N. Lewis, a student. You see, that is a thing of science. Your grandfather, father, just like at home in your family. Academic grandfather, academic grandfather, that tradition, you can never forget, you can learn it in science. You are the great scientists are on your shoulder. You are riding on their shoulder. You are riding the shoulders of great men. And I will never forget our origins. But for J.N. Lewis's idea. In fact, when I used to work as a young postdoctoral in University of California, Berkeley, in 1950s, the ghost of J.N. Lewis, we could feel that. And this is the great man, J.N. Lewis. And this is Linus Pauling, see. He got the Nobel Prize in 1954 for chemical bond after he discovered the alpha helix, the great chemist. And of course, he is my grandfather also, because I got my PhD under his student, so my grandfather. But I want to tell you one or two stories of a different kind. Well, many of you don't know, because if you don't know IIT, I can't tell you. I'm an IIT man from way back. I was in the very first IIT and later was a professor in IIT Kanpur for many years, for 15 years. I have taught some of the brightest children, brightest young boys and girls in the world in IIT. IIT's Kanpur, the students I taught, I never taught such students either in Oxford or Berkeley. Fantastically bright. Unfortunately, they all have gone astray. They sell soap and make money. They are all left for engineering inside. And those bright people could really contribute to science and engineering in a big way. Don't give up science and engineering. I tell you why I have given Hans Bethe. Hans Bethe's story is very important for young people to know. You know, at the age of 20, he finished his undergraduate work, whatever it is. He wanted to do PhD. Again, who does he go to? The man I showed earlier, Sommerfeld. Sommerfeld gave a problem. Work on the energies of ions in crystals. And forget about the problem. 2 years later, Hans Bethe writes a thesis, goes and presents it to Sommerfeld. Here is the work I have done on this ion energies of ions. It is what is now called crystal field theory. He had discovered the entire field of crystal field theory as part of his PhD thesis. Actually, he should have got a Nobel Prize for his PhD thesis. He didn't get it. But he got a Nobel Prize much later. Hans Bethe was that type of man. At 23, he got his PhD, and then unfortunately, he was appointed an inspector, assistant professor, whatever. Unfortunately, Nazi Germany, being Jewish, he was not allowed to teach. So he had to leave Germany. Eventually, he goes hanging around somewhere in England. At that time, another Jewish person who also had left Germany was in Birmingham, the name Peierls. Those who are in physics will know Peierls distortion, a great physicist. So he was staying in his house as a friend. And there was a symposium in Cambridge at that time. And the symposium was something about the latest thing about neutrons and so on. And this young boy, 23-year-old, along with Peierls, go and attend that. And then they finish the symposium and come back to the railway station, the real story, railway station, to go back to Birmingham from Cambridge. And then the man comes running to the railway station, Chadwick, who had just discovered neutron. Chadwick comes and says, "Hey, I hear that you two are very bright, both German trained under Sommerfeld, very good theoreticians. There is a very important problem I want you to work on. Why is it light-induced decomposition of Teflon? Teflon is nothing but neutron. Neutron goes to neutron and proton. Why does it do that? You please work it out." And this man said, sure, we will work it out. This was in year 1929 or 1930. And you know what? By the time they reached Birmingham from Oxford, they had solved the problem. And that was published in Proceedings of the Royal Society. Very famous problem of nuclear physics. What do you think? You guys are there, some of you. India has Hans Bethe's. Many people, young children like you, pardon me for calling you children, young boys and girls like you, that are 80 years old, I call you children. You know, you are right, you can do that. We need people like Bethe. Problem solving, you can use something, this problem is solved. Then brain. Bethe was there. Because Bethe did the same thing once more. Then he went away to Cornell as a faculty member. And there was a very famous meeting. In fact, I didn't want to tell you this, but suddenly I remember it. There was a very great meeting in Washington many years later. Freeman Dyson, the great theoretical physicist, has written about it recently in an Institute of Advanced Study publication. There apparently, the meeting was, there was something called the lamp shift. People had measured what is called a lamp shift. I will have not time to tell you what it is. Anyway, people wonder, what is the origin of this? Do you need relativistic quantum mechanics or arbitrary quantum mechanics? How do you explain that? So, Hans Bethe attends this meeting, and he again takes the train back to Cornell University from Washington. So Ithaca, New York. And then, and people tell him, do you think you can work on that? He sat and worked out and showed you don't need relativistic quantum mechanics. He calculates the action exactly sitting in a train. And there's a famous paper of Hans Bethe. The reason I'm giving you this example is there are young boys and girls in our IITs and somewhere who have the brains like that. I don't have it. I'm not so sharp that I can just solve problems like that. There's a different kind of mind, and my mind slowly doing things and coming with big results. Some people can sharply just solve that. And I think India needs that. India needs physics and chemistry in India, biology in India, engineering in India, needs minds in India. That is why I'm giving this example. Don't let us down. Please, some of you young people, because I won't tell you if you complete like this. Of course, once I put my hair like that, I also look like Einstein. But okay. For science to thrive, you need humanity. You need generosity. You need tradition. I talked about tradition, why I call Polly my grandfather, J. Lewis my grandfather, and our Oswald as a great grandfather. It's just to show there is something common. And what I cannot forget to tell you is I'm a failure of my generation. Every generation has failed the youth. There is no generation in the history of mankind that has answered the call of the youth. There is a failure of mankind. And we are now a bigger failure than before. Before there was no competition, there was no science, it was easier to deal with questions that the youth raised. Today youth has bigger questions, particularly in India. What is the future of education? What is our future? Where are the opportunities for doing good work? Where will India go in science? When will India become competitive? There are many, many questions. And where do we belong in this big universe? The youth asks, on the shrill voice of the youth, we fail to listen. To me, you are a good scientist, you have to work with young people and treat them as full-fledged human beings, full-fledged collaborators. When you are a young boy, you are an old man, doesn't matter in science. Science is independent of age, independent of color, creed, nationality, everything. As Louis Pasteur said, science has no country, it deals with humanity. Science is that. And to me, we have to learn in India to treat young people better, give them more respect, answer their call. Their shrill voice, their shining eyes need some answers. We have to do something for the young. And that is the main thing, we have to do something there. I again show my hero to close my lecture. What, in my own case, it is chemistry that stole my heart, other than my wife. My wife has been so wonderful. We have been married for 54 years. It has been a wonderful life, and I can't think of a better life than that. And that and chemistry, I want nothing else. In fact, no money, $1 million a day, I don't want it, you can keep it. I want no money. Nothing is important. Seeing wonderful results coming, my young children, my young students, I don't know my children, young students doing well, and seeing my name in print. That is the disease I have. I like to see my name in print in papers. So I got, that is a disease I got many years ago. And that virus has not killed me at 80, I'm still okay. So that virus is not a bad virus. So please remember, let some healthy virus catch you. And that virus should be science. That virus should make you work better, look forward to better life, because your work keeps you. It is your work that keeps you engaged. It is your work that keeps you, make your life worthwhile. It is your science that makes the entire thing meaningful. I wish you a great scientific life. Thank you.